Okay, I'm a day late on this one. Like I'm doing day 6, but it's actually like day 7 right now. I still have an hour and a half before it's day 7. But I was traveling last night and I stayed out late and I had to wake up early, so I didn't get to do it. So now I'm gonna do it and catch up, and hopefully it will take me less than an hour and a half so that I'll be able to do day 7 right on schedule. So, and then the other thing I did was that if you watched my day 5, I took that code and like refactored it pretty seriously under the idea that I would have to um, use it again. So um, hopefully I don't have to use it again today, but I'll probably have to use it again at some point. So um, uh, it's there. So let's see. You've landed at the Universal Orbit Map Facility on Mercury. Because navigation in space often involves transfer between orbits. The orbit maps here are useful for finding efficient routes between, for example, you and Santa. You download a map of your local inputs. Except for Universal Center of Mass, every object in space is an orbit around exactly one other object. An orbit looks roughly like this. This diagram, the object BBB is an orbit around AAA. The path that BBB takes is only partly shown. Map data, this orbital relationship is written AAA. Okay, so BB, got it. For user map data plot, of course, you need to make sure it wasn't corrupted during the download. To verify maps, universal orbit uses orbit count checksums, the total number of direct orbits like the one shown in indirect orbits. Whenever A orbits B and B orbits C, A indirectly orbits C. This chain can be any number of objects long. If A orbits B, B orbits C, and C orbits D, then A indirectly orbits D. For example, suppose you have the following map. What's COM? Center of mass. B orbits center of mass, C orbits B, D, blah, blah, blah. Usually the map of orbits looks like this, which is, okay. This visual representation, when two objects are connected by a line, the one on the right directly orbits the one on the left. Here we can count the number of orbits as follows. D directly orbits C and indirectly orbits B and COM for a total of 3 orbits. L directly orbits K and indirectly orbits J, E, D. So basically we're building a tree, and for each element we want to know how many ancestors does it have. L directly orbits K and indirectly orbits J and COM. Total number of direct and indirect orbits in the example is 42. What is the total number of direct and indirect orbits in your map data? To begin with, get your puzzle input. Okay, so that's a lot of puzzle. So let's save as and I'll just copy it, that's easier. So let me go here and add some, that didn't work, add some input.text, and I've been using a Mac for the last couple of days, so I'm gonna get the control and the alt mixed up because it's in a different place on a Mac. Anyway, and so let's get their example, and so we can use it for a unit test. So following map, and we'll just use this to work with. So something like this, and we know that if we build a tree, each thing orbits its ancestors. So we need to count the total number of ancestors. And so let's think about how we would do that. So from typing import named tuple, and then we'll say an orbit is a named tuple, and how did we call these things? Orbit is an orbit around around blah blah blah. So how do I want to call it? Orbiter is a string, and orbited is a string. So, and let me, and you know what? I'm actually going to just say parent and child. That's easier because we know what that means. And so So let's just say static method from string, because from string, it's going to give us an orbit, and we're just going to say parents child equals s dot strip dot split on this thing, and return orbit parent child. So that's going to take this, and now what we want to do is we want to count ancestors. So there's a couple ways to do this. The most obvious one is to build a tree and then just say, and then kind of traverse it. So that might be a goofy way to do it, but orbit is a list of orbit, and I don't want to define the return type because it's going to be a pain. So I'm just going to ignore that, and I typoed list. So let's do this. So let's make a tree. So let's say, tree is this, and actually let's make tree a default dict from collections import default dict. Actually, I don't think I need a default dict. Well, I'll leave it there anyway. I'll just do this, and I'm just going to call this parents, and then I'll say for parent child in orbits, parents child equals parents, and then return parents. Okay, so that's not doing much. And so let me just write this and let's say orbits equals orbit from string s for s in raw dot strip dot split on new lines, and IPython run day06.pop need to go in the directory, and let's look at the orbits. So that sounds good. And then if I do make tree of orbits, I say k's parent is j and l's parent is k, and so that looks right as well. And now well, I'm just going to do this inefficiently because it looks like it doesn't really matter. Count ancestors of child, which is a string, and then tree, and that's going to return an int. Let's say count equals 0, while child is not equal to, and we have the sentinel value, which is com. Count plus equals 1, and child equals, let me do parents, which is a dict from string to string, and now I can actually annotate that correctly. So it probably shouldn't even be called make tree, but I'm just going to leave it for now. Child equals parents child, and then return count. So, let's say parents equals make tree of orbits, and let us look at their examples and assert that D has 3 ancestors, L has 7 ancestors, com has 0, ancestors. So let's just assert those things. Assert that count ancestors D and parents equals 3. Assert that count ancestors L parents equals 7, and assert that count, and we should probably cache some of these, but so ancestors com parents equals 0. So let's save that and let's run it and see if it causes any problems. It doesn't, so that makes me think it's right. So now what I want to do is I want to count orbits. What do I want to call this? Total number of indirect, so let's say total orbits. Total, I'll call it total ancestors. Orbits is a list of orbits, and that goes in int. And every person's going to, so let's say parents equals make tree orbits. And then I would just want to return sum of count ancestors of child parents for child in parents. And now I want to assert that total ancestors of orbits is, and what did they say that should be? That should be 42. So let's assert that that's 42. And now let's run that, and that seems to pass. Okay, good. So now with open input.text as f, orbits equals orbit dot from string line for line in f, print total ancestors of the orbits. So let's do that and now run it. And I'm not in day 06, so that's probably the problem. So now let me do this, and it's saying 271,151. I have no reason to believe that that's not a good answer. So let's, okay, I didn't copy it. This is what I mentioned about the Mac thing where I hit Alt instead of Control, and actually that's not this thing. This is something different, which is that this is like a little Linux terminal, so I have to do Control-Shift-C to copy, which computers, who needs them, right? Now I'd Control-V, submit, and that is the right answer. Continue to part 2. Now you need to figure out how many orbital transfers you need to take to get to Santa. You start at the object you are orbiting. Your destination is the object San is orbiting. An orbital transfer lets you move from any object to an object orbiting or orbited. For example, suppose you have the following map. Visually, the above map of orbits looks like this. In this example, you are in an orbit around K, and San is in an orbit around I. To move from K to I, a minimum of 4 orbital transfers are required: K to J, J to E, D, I. Afterwards, the map of orbits look like this. What is the minimum number of orbital transfers required to move from the object you are orbiting to the object San is orbiting? Between the objects they're orbiting, not between you and San. So that's saying to get from K to I. So the way to think about this is what we want to do is the shortest way to go there is going to find their closest common ancestor. And so one way you can do that is basically by constructing the path to com and then working from there. So what do I mean by that? I can say def path to com, which is going to be what do I want to call this? Child, which is a string, and then parents, which is a dict, a string, and that's going to return, let's say, a list of strings. And what I want to do is Um, do I want to include myself in there? I don't. So let's say path equals this. Um, while child is not equal to com. Well, maybe I will edit. Um, path dot append. Um, um, while child is not equal to com. Child equals parents. Child to go to its parents, and then append that to the path. So uh, path dot append child. So that way we won't get the first one. And if we decide we want it, we'll put it back. And so then we'll return path. And I'll think about what I want to do with this in a second. But here uh, in I want to say path to com from I. Is that the same? Yeah. Um, so assert the path to com from I uh, and parents is. Um, and now let's look at what this is. It's DCB com. So CB com. So let's just run that and make sure that that's right. And that's right. And let me comment out this thing as well because we don't need that every time. So that gives me the path to com. So that's good. So now what I want to do is I want to find shortest path, child 1, which is a string, child 2, which is a string, and again, parents, which is a dict from string to string. And that's going to return, let's say, an int. Maybe I want to return the path. Anyway, what I want to do is path to com1 equals path to com child 1 parents. Path to com2 equals path to com child 2 parents. And so now let's think about their example, which is that in the Santa one, for me it's going to look like JEDBC com, EDBC com, and then also we're going to have from this guy DBC com, DBC com. So we probably want to reverse them. So list reversed. Actually, I don't want to do that. I don't want to reverse them. Let me do it this way. This will be a quicker way to do. So what I want to do is, as long as things are while path to com1 and path to com2 and path to com1. So while neither of these is empty and their last elements are equal, what do I want to do? I just want to pop those off. Path to com1 dot pop, path to com2 dot pop. Okay, and so what will happen is I'll pop off com, I'll pop off c, I'll pop off d, I'll pop off d, and then I have empty, and then I have this j and e, and I want the length of what's left because I'm going to have to traverse those, and then +1 to get to D and +1 to get to the other one. So using this, I pop, 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 and now I have I to san, and how did I lose the I somehow? G, E, DBC com, and then I think I lost an I. IDBC com. Okay, so, and let me just, and so now I have J and E, and I have I. And so I want to count those up and then add one more for their common ancestor. And so that is return. So len path to, you know what? I'm just going to rename these so that my life gets easier. Path 1 and path 2. While path 1 and path 2 and path 1 minus 1 equals path 2 minus 1. I'm just going to pop off and throw them away. And so now len path 1 plus len path 2 plus 1, and the 1 is for the transfer. And in particular, I want to assert that the shortest path, and again, from the parents, right? So I want to assert that the shortest path from I to K is 4, and let's put a couple more in. So what about H to F? So I got to go 1, 2, 3, 4, 5, 6. So H and F has to be 6. And I was just pointing at my screen. I know you can't see when I point at my screen. Okay, so shortest path I, K, parents is 3. And why is that? That is because okay, so I'm going to do I to K. So I screwed something up. So K is JEDCB com. JEDCB com, and I is IDCB com. CB or BC? Doesn't really matter. CB. Okay, so while these are true and that one are equal, pop them off, right? So pop off com, pop off this, pop off this, pop off this, and then I get print path 1, path 2. So let's just print it and see what it prints. Empty and JE. So why is it empty? It's empty because I said shortest path from I to K, and I think I just wrote the test wrong or something. No, I didn't write the test wrong. So I think I want to include, so let me change this a little bit. I think I want to include the child to start with, and then I want to subtract 1 because I'll get an extra 1 for each. Let me try that. And now I've broken that assert because there should be an I in here now. So let's try this one more time. And that still didn't work. And it still didn't work because I have an I and I have a KJE. So what have I done wrong? I have an I and I have a KJE. So why am I popping off the D in one of them? So let me print path 1, path 2. So IDCB com And K, why am I getting a K in there? I'm getting a K because I included K now. So I pop, and I get all the way to IKJE, which uh, IKJE. Um, and so then I don't need to subtract one at all. I just need to add them up because it works out correctly that way. And then that way it works. Okay. So off by one error is the bane of my existence, but that's okay. And now let's go back and see what it's actually asking us. It's asking us, what is the minimum number of orbital transfers required to move from the object you are orbiting to the object SAN is orbiting? Okay. So now let's say print, and so we have this orbits, right? So we can say parents equals make tree of orbits and print shortest path from child one is going to be parents of, and how am I represented? I'm represented as you, and and then Santa is represented as parents of San, and then using the parents thing, and that should be good. And now let's run that, and it says 388. So let's try 388. That's the right answer. 1 gold star closer to rescuing Santa. Okay, so that's good, and it didn't take 26 minutes. That's not too bad. So depending on how I'm feeling, I may be back in an hour to do tonight at 9 p.m., or I may not because I'm tired and I want to go to bed. But yeah, so anyway, we're done, and that was not too bad, other than some stupidity on my part, but it was good. All right, cool. See you next time.